I'm Gary Vanderplaats. Garrett, if you're mad at me. Juan Pablo Leiva is sitting right here. And I want to talk about optimization. Now, optimization in engineering has been around about 50 years. And despite that, it seems the usual response when I talk to someone is something like this. Maybe not too surprising, because even the experts can't agree on how to spell optimization. US, it's one way, Europe, it's another. But despite our inability to spell it, I think we now know what it is. And basically, optimization is a tool that will automatically change important parameters to find the best design satisfying criteria. So in other words, if you have an analysis program, piece of software, optimization will change the inputs to improve some of the outputs with limits on other outputs. Some things are not optimization that often are confused with it. Design of experiments, parametric studies, univariate search, and so on are not optimization. Optimization changes all of the variables all of the time. Why use it? Reduce design time and cost, improve quality, free us to innovate and think the great thoughts we know God intended us to think. If we reduce the gasoline consumption 1% at $2.50 a gallon, we save $3 billion annually at the pump. That doesn't include all the additional savings in materials and so on. 10% reduction in automobile mass will reduce fuel consumption 7%. The good news is that the learning curve has gotten very short in the last few years. You don't have to be an optimization wizard. You can be a novice user in a day, pretty capable in a week, and quite capable in a month. If you're under 30, cut this timeline in half. If you're over 60, find something else to do with your time. Note that it says computer literate. An example, hybrid vehicle, one-day study, 5 minutes on a PC, increased fuel, reduced hydrocarbons and nitrous oxides, beginning with the best design NREL had created in several months of study. Airfoil optimization, a 2-day study, 10 minutes on an HP workstation. You want to optimize the mold fill so it fills at the same time at both ends. You may not want to do that, but if you want to, optimization can do that. It can also design the mold itself so that all this gooey stuff doesn't come squishing out the cracks. Car body, in this case we want to find where to put material in an SUV to make it light and stiff. This was a one-day study, 35,000 design variables. In practice, in the stuff that we can't show, production problems are about 2.5 million design variables and take about 20 hours on an IBM mainframe. Formula One people, Martin Gambling in Europe went to the Formula One people and said, I can reduce mass of these bodies, and they laughed at him and said, we spend our life doing that. He said, well, give me your best design, and if I don't impress you, I won't come back. Came back a day later with an 18% mass reduction, and the Formula One people today are virtually all using optimization. So I think that I would argue this is the next big step in CAE or MCAE. We have very good analysis tools across the range of crash, linear finite element, CFD, et cetera, Optimization can change the inputs to those codes to improve the outputs. What we haven't done yet is really integrate that under a CAD environment. There's been steps taken at that, not complete, but we're on our way. And I think that's the big step that's needed to make better, cheaper, more efficient systems in less time, and presumably improve the bottom line of the people using it. And we do see companies, I know one company that is now making standard practice that optimization be done wherever possible. So that's the story, and I'm almost a minute early, and yet I only have one thing left to say. Thank you.